then we need to solve by any of the method to find out the feasible solution, right? So this is a question which we solved yesterday, I think. Yeah. Or else we'll go to the second question. Okay. So first we need to find out the feasible solution by VAM method to find out the optimal solution. The same thing what we discussed in the linear programming problem as a graphical method. We draw the equation lines on the graph and we found the feasible area. Within that feasible area, there are some points we are getting, some are intersecting, some are on the axis. So those points we considered it as the feasible points. Among all those feasible points, whichever is optimal, that we found by finding out by substituting those feasible points in the objective function and finding out the best solution. That is, either it may be a maximum or minimum. So if it is a maximization case, then we found by finding out whichever is the maximum among all the feasibility. Here also the same procedure we are following to find out the optimal solution or best solution. First, we are finding out the feasible solution by means of VAM method. So how to find out the feasible solution by VAM method? I told row wise we need to find out the penalties. To find out the penalties, what to do? I said the least and the next least, the difference between, right? The least here in this one is 7 and next least is 10. So the difference is 3, right? Row wise penalties. Then here 6 and the 9 difference is again 3. And here in this 8 and 9 is the least and second least. So the difference is 1. So whereas in the column wise, if you see, the difference of 8 and 9 is 1. And difference of here 9 and 12 is 3. And here the difference of 11 and 12 is only 1. And here the difference of 6 and 7 is 1. Among all these penalties, there are 3 as a highest penalty. That too 3 times we are getting.
Incoming voice call from +91 94,949 84,464.
Hello?
Hello, sir. Can you mute your mic? Yeah, thank you. Right. So among all these penalties, the highest penalty will search, but the highest penalties 3 we are getting thrice, 3 times. So what we do is
D4. D4 6.
I didn't get you.
It's D4 6, right, sir?
D4 6. Because why? Because can you tell me?
It's a low cost.
Right, very good. Among all these highest penalties, if you search the least cost cell is this cell, that is B4, B row and D4 column. So
Yes, sir.
this cell we need to allocate. So to allocate it, what we need to do? Total demand and the supply, whichever is that
6 into 30.
So 60 into 30 will be getting us the least cost, which is 1, so that this 30 becomes 0. So that means
And
there is
40
no
becomes
further
10.
allocations for this.
Yes, sir.
Right. So you can do it now. You can do it easily.
40 become 10.
You don't have the time to do it.
Yes, sir.
Yeah. So So here this column is totally exhausted, right? And
Yes, sir.
this column doesn't have highest penalty. We got a highest penalty row wise. Any
Yes,
of
sir.
the least cost, for that least cost, we allocated 30 units. Now, again, we need to go through the next penalties. So if
Yes,
you
sir.
find out the next penalties, if
1,
you see the least is 10 and the second least is 11. So the
1,
difference is 1. Again,
3,
the next, your 9
3,
and 12 is 3. And
and
the
1.
next, and the 1. Very good. Column wise, if you search the same 1,
Same is
you're
1, 3, 1.
saying 3, you're saying 1. This is exhausted. We can't allocate for this one. Okay, can't find
Yes,
out.
sir.
Now again, the 3 and 3, the same row, same column, we are getting it. So among this row and the column wise, if you search, so the column wise, the 9 is the least one.
9, 9, 2 nines are there, sir.
Yeah. There
2
also,
nines are
the least is twice we are getting. Very good. So here in this, these 2 nines, whichever the cost is less, that is to be allocated first. So here if you see this 9, row wise total 35, column wise 80. Whereas for this 9 to allocate it, the row wise is 10 and column wise is 60. Both are less. So this is to be allocated first.
9 into 10.
9 into 10. Right? So this 10 out of 40, the total things have been allocated. So it becomes 0. And here it becomes 6. So whereas this column is totally exhausted. Right. So that is allocated. So this row and the column, second row and the fourth column as exhausted. So there is no further calculation of penalty. So again, we need to find out the penalty. The row wise penalty, if you search, the 1 is the penalty for this. Here it
0.
is nil, 0.
Nil. And 1.
And here it is again 1. Column wise, if you see, here the
2.
difference is
2.
2. Here the
9.
difference is 9. And here
1.
the difference is 1. So among all these things, the 9 is the highest penalty. So to allocate it, the least value is 9. To this, we need to allocate the
9
least
into
number of
18.
units. So 9 into 18 we need to consider. So that this column becomes 0.
17.
Out
35
of
by
35, 18 columns, remaining is 17. Right. And here there is no
8.
further allocations for this column. This becomes 0. Right. Again, if you find the penalty, 10 and 11 difference is 1.
1.
8 and 12 difference is 4.
4.
And here 2 and 1. So 4 is the highest. Right. Otherwise. Among all these penalty, the highest penalty is 4. So that means to
4.
this row we need to. So least cost is 8.
8
To
into
this
6.
8 we need to allocate means
6.
8 into 6. Okay, this becomes 0.
0.
What disturbance is going on by the viewers? Right. So we allocated 6.
Only 11, 12 is there, sir. 11 we can allocate. D3 column.
Okay. Now the last column, that is D3 column, is there, 11 and 12. Among these two things, the least is 11. So to this we need to allocate. To allocate, how many units are less?
11 into 20.
20.
Zero.
And this becomes 11.
11.
So here
11. 12 into 11.
12 into 11. Radhakrishna sir, hello.
వాళ్ళు ల్యాప్టాప్ తెచ్చుకుంటారు కదా
Radhakrishna sir,
Now okay.
sir again, so out of, actually here we did not reduce after allocating, left over is 11. So here we need to allocate 11 units to this, so that this and this becomes 0. Right?
Yes, sir.
So the allocations, how many allocations? 1, 2, 3, 4, 5, 6 allocations we got. Right?
Yes, sir. Yes, sir.
So after getting the solution, we followed m plus n minus 1, that is 3 rows, 4 columns minus 1 will be allocation. So 1, 2, 3, 4, 5, 6 allocations we got. Right. After getting the solution, whether the solution is optimal or not, we need to check. Means we need to go through somewhat an exercise, additional exercise. We need to assume that the row wise, the 3 rows, we consider it as U1, 2, row wise U3, and column wise V1, V2, V1, so there are 4 columns and 3 rows. So whatever the cost is given to us, this cost is considered as the cost of the cell, and we need to consider this in the formula wise as Cij is equals to Ui plus Vj, where U is the row, V is the column, Cij is the cost of that cell. So Cij cost is verified with the U and Vj for occupied cells. By considering only occupied cells, we need to assume that any row or a column by cells, whichever cells have been occupied, those cells cost has been occupied with the particular units. Whether those units are correctly occupied based on the verification part. So what we are doing it first, we are finding out the values of U and the V based on the occupied cells. And for the unoccupied cells, we need to check the cost, whatever given to us is exactly we are getting positive value or in the negative. If any unoccupied cells are getting us in the negative value, then we need to go further steps to find out the number of units whichever are allocated to a particular cell. Those are not exactly correct. That is to be transferred to the other cells. So how do we know? So first we need to find out these U and V values with the occupied cells. Which are occupied cells? Which occupied cells in the sense the number of units which we allocated based on the VAM method. So we got the cells is A, D3, first row, third column, that means. Then second row, first column, second row, fourth column, third row, first column, third row, second column, third row, third column. So assuming that the rows in the columns, we are considering the occupied cells. Assuming one more thing here, I'll write it, how many cells have been occupied. C13, C21, C24, C31, C32, C33. So all these are occupied cells occupied by the number of units, some units, which we allocated. Among all these things, maximum occupied cells is in the third row. So for that reason, we are considering anything can be considered, but third row is occupied more. So U3, assuming that U3 is 0. So what are the values of V1, U1, V2, V3, V4? We can find out it by considering the cost. So 31, C31
48.
nothing but U3 plus V1, right? V plus V1. So what is the cost of this cell? 8 is the cost. So 8 is equals to 0 plus V1. That means with this equation, what we got, V1 value. Are you getting my point? Hello? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
So what we did is we assumed U3 as 0 for the occupied cells. So third row, first column, cost is 8. If you consider that, V1 value we are getting as 8. Similarly, if you go with this cell, C32 is nothing but U3 plus V2, where U3 is assumed to be a 0. So cost of 32 cell is 9. So 9 is equals to 0 plus V2. Therefore, V2 value is obviously getting it as 9 itself. Similarly, for the third, as U3 plus V3. So based on this, cost of that cell is 12 is equals to U3 is 0 plus V3. So if you consider that, V3 is equals to how much? 12. We got all these values that we can substitute here. C13 means what? That is equals to U1 plus V3. Right? Is this clear to you? So U1 we don't know, but V3 we calculated and we got 12 as a value. So C13 cost is actually 11. 11 is equals to U1 plus 12. Therefore, U1 equals to how much is the value? What is the value of U1?
Minus.
Minus 1. U1 equals to minus 1. Right. So similarly, here C21 U2 plus V1, where we know the V1 value. So we can take it into consideration. 21 cost is actually 9. 9 equals to U2 we don't know. U2 value we need to find out, plus V1 value we got as 8. Right? If you substitute that in the place of V1 as an 8, U2 value we are getting as how much? Plus 1. Am I right or wrong? Equals to U2 plus V4. Here we can find out the value of V4. C24 value cost is 6. 6 equals to U2 already we got on above is 1 plus V4. Therefore, V4 value is how much? 5. Am I right or wrong? Just go through it. Any doubt you can clarify. V1 value we got as 8. V2 value we got as 9. V3 value we got as 12. V4 value we got as 5. U1 value we got 1 minus 1. U2 value is 1 plus 1. U3 we assumed it as 0. This is only by means of occupied cells you can calculate. Then for the verification purpose, we need to go through unoccupied cells. Unoccupied cells cost, with that we need to substitute these U and the V values and verify whether the cost and this is correct or wrong. To verify it, what we need to do is unoccupied cells. For the unoccupied cells, we need to go through the formula. The formula is delta. Delta ij is equals to Cij minus ui plus vj. The verification part which we need to do with the unoccupied cells. So this delta ij, if all the values are 0 or a positive, then we can say we reached our optimal solution. Same in the simplex method, what we have verified at the end. If we reach the position where all the values of dij, delta ij is positive or 0, then we can say we reached our optimal solution. If there is any negative value we are getting, then we need to go further steps. That is actually the verification part we need to do. As I told you, this WAM method, whatever we are doing, that WAM method mostly will be near to optimal or sometimes optimal also. Only one step beyond the optimal solution. So first, which are unoccupied cells that we consider? Which are the unoccupied cells? D11. Right? Getting my point? Unoccupied cells we need to take. This is one unoccupied. This in the first row there are 3. That is D11, D12, D11, D12, D14. If you didn't understood any of the point, you can ask the doubt. No problem. One, 4. Then second row, there are unoccupied cells are 2.
2, 2, 2, 3.
2, 2,
2, 3.
2, 3. And in the third row, there is only one cell, that is 3, 4.
4.
Third row, fourth column. Right. These are the unoccupied cells where we need to cross check that Cij minus ui plus vj. So Cij is nothing but the cost of that cell minus ui is the value which we got here as that value to be considered. Like example, if you consider this, Cij is nothing but C11 cost minus U1 plus V1. So what to do in this one? Cij cost is actually here. How much is the cost? C11 cost is 10 minus of U1. What is the value of U1? Minus 1 plus V1. V1 value is 8. So substitute those values in actual equation. Then you can know what is actually solution part. So 10 is the cost of that cell minus of U1 value is minus 1 plus V1 value is 8. 8 minus 1 is 7. 10 minus 7 is actually, we are getting Dij value that is 3, so which is a positive value, which is a positive figure. Similarly for the 1, 2, C11 cost is how much? Sorry, D12 cost is 18, right? Minus of U1 is nothing but minus 1 plus V2. V2 value we got as 9. Is that clear? 1, 2. C1 value is 18. 18 minus of minus 1 plus 9. 8, 10 minus 8 is nothing. 10 you are getting. That positive value. Then 1, 4. Cost is actually the 7. 7 minus of minus 1 plus
5.
V4. V4 value is 5. Right. So 5 minus 1 is 4. 7 minus 4 is nothing but 3.
3.
Right. Then D22. Second row, second column is nothing but cost is 12. 12 minus U2. U2 value is 1 plus V2. V2 value is 9. 1 plus 9 is nothing but 10. 12 minus 10 values. How much you are getting? 2. Similarly, 2, 3. The cost is actually 14 minus of V2 is 1. U2 is 1 plus V3 is 12. 12 plus 1 is 13. 14 minus 13 is nothing but 1. And 3, 4. The cost is actually 10. 10 minus 4. U3 value is 0 plus V4 value is 12.
Minus.
No, V4 values, sorry. V4 values 5 only. Is it not? V4 value is 5, no?
Yes, sir.
V4 value. So V4 value is 5. 0 plus 5 is 5. 10 minus 5 is nothing but 5. So what I am telling you is these values, unoccupied cells resulting figure, whatever we got, these values must be positive or 0. Then we can say we reached our optimal solution. Means the solution whatever we got by these occupied cells is an optimal solution only. In case any one value we got as negative, then we need to make a loop so that the occupied and unoccupied cells has to be transferred somewhat units based on the loop. So we got all in the positive values only as Dij for the unoccupied cells. So the procedure is saying first we need to transfer some units from some cells to another cells with the loop. That can be explained if you got any one cell as a negative. Assuming that D23, this one, you got as minus 1. Okay. This cell is getting as negative value. Then it is to be assumed that to this cell we need to prepare a loop from here you need to go and find out cell which is occupied and another unoccupied, then occupied. You need to make a loop like here. One example. Here is the loop. We can find out. Here we got as a negative value. So from here to here occupied, here to here, then here to here, we need to make a loop. This loop expresses that from one place to another place, the occupied cells units has to be allocated. So which is to be occupied and which is to be unoccupied. To the unoccupied, we need to add some units so that it is positive sign to be considered. Unoccupied, occupied cells negative, then positive, then negative. So from these minus signs, wherever we are finding out, from that the least number of units, whichever are there in whichever cell is there, that is to be subtracted and added to these two cells. That means this 125 units, whatever are there, those units are to be added to these two cells, this cell and this cell, and subtracted from here, and from this cell and this cell we need to subtract these least number of units as 125 units. Then the allocation will make difference. This becomes 0, this becomes 125, this becomes 125, this becomes 275. So this loop has to be prepared when we are getting as a value as minus figure. If this any of this value is minus, then we need to consider that as the place where we need to allocate the number of units which we did not allocate it. So now we
Sir, go to the previous picture. Go to previous picture, sir. Loop one. Loop with this. I didn't get, sir, this one.
See,
I didn't understand.
here in this cell we got as minus value, -1 or minus negative value. So
No,
what
anything
we
like
made is made a loop from here to somewhat occupied cell. Here it is occupied. And
Okay.
from here to another occupied or unoccupied cells down, then the next occupied cell to this again.
But why don't we go to 175, sir?
Further, here 175. You
Yeah,
can
it
go
is
to
a-
the 175, but the thing is least units to be seen first. The least
Okay.
number of units. Right.
Okay.
So
If we go to 125 to 150 is the least one, okay. What about the 150 to 250 is the highest, right?
see, this loop has to come back to the same place
Okay,
from where we
okay.
started.
Okay, sir, okay.
Right.
Okay, okay, sir.
So first of all, we need to see unoccupied to occupied. Then unoccupied is also there. We can go down. Then occupied, then unoccupied. Here already two are occupied. Anyhow, this is a loop which we framed. We need to go with the least number of units.
Okay, how we are deducting, sir, this one? 14 minus 125.
So wherever we got as minus negative value, to the
In
cell,
10.
we need to consider plus. The next loop started from here to there, minus, then plus, then minus, alternate. Plus, minus, plus, minus.
Okay, okay. Not just multiplying. It's plus
No,
or
no,
minus,
no.
right?
It is loop whatever we framed. So from the point where we got as a negative, from there only started the loop. From there only we need to allocate the signs as plus, minus, plus,
Plus,
minus.
minus. Okay, okay. Understood.
Alternative. And
Yes, sir.
we got minus in two cells, right? In these two cells, the least number of units only to be subtracted from these minus cells. So 125 is subtracted from this cell as well as from this cell. And the same 125 is added to this positive cell, plus sign cell, here and here. Then how it appears, 14 becomes 0, whereas in the cell of 10, we'll be having an allocation of,
10 plus 125.
10 into 125.
Into or plus?
125 plus, no, it is into only. Plus we have kept as a sign to add or subtract what we need to do in which cell. To understand in which cell we need to subtract and in which cell we need to add.
Okay.
And for 13, the number of units increases. 150 plus 125, 275 comes to. We need to add that 125 units here. And here for this cell, the units will decrease because it is having a minus sign. So 250 minus 125, here it is. Now the new allocation we need to make with this one only. So the cells already, other cells are somewhat occupied and some are unoccupied, but the new cells with these new figures only to be considered. Means in the place of this, these cells are here, you're finding out these cells. These cells has to be replaced with these number of units. Are you getting my point?
Yes, sir. Yes, sir.
This 125 units are allocating to this cell and subtracting from this and added to this. So again, the new allocations will come to us, right? So again, occupied cells will be there and unoccupied cells will be there. The procedure again we need to follow in the same way what we did here. Now, just now. Again, we need to go to these two steps again. Occupied cells, finding out U and V values. Again, those U and V values to be substituted and finding out for the unoccupied cells, all are positive or not. All the values are greater than or equals to 0, then we can say we reached our optimum solution. Any one value is in the negative, we have to frame a loop again. We have to make a loop.
Okay.
That is actually the stepping stone also, as well as MODI method, modified distribution method.
Okay. Sir, here in this case, why we have taken U3 equal to 0?
Anything can be assumed. You can assume U2 or U1.
Anything can be 0.
0. One value, we need to assume it as zeros to find out all other values. Why I took a U3 as 0? Because maximum occupied cells are in the third row only. So third row is assumed to be 0 so that you can get all other values easily.
Okay.
Sometimes you may get all the rows equal occupied cells, 2 units, 2 cells. Right?
Yes.
You can assume anything. It is not mandatory that U3 only. It can be U1 or U2 or U3. Can be assumed as 0 to find out all other values. Right?
Yes, sir.
This is MODI method to do this optimal solution.
Sir, is it MODI method or VAM vowels?
No, it is VAM method we did to find out a feasible solution, right?
Okay.
We got occupied cell somewhat. Is that feasible solution is an optimal or not? We are verifying with the MODI method. Whatever we did, all these things is a MODI to find out the feasibility. After VAM only, we can go with the MODI method.
Okay.
Means what I want to say you is, to find out the optimal solution, first of all, you must know where is the feasibility. So to find out the feasible solution, any of the methods you can do it, either northwest corner method or least cost method or VAM method. I choose VAM because I told you now, the VAM is almost near to the optimal, or sometimes like this, what we got as optimal directly. Go with the northwest corner method, somewhat occupied cells you will be getting. Again, we have to apply the MODI method by this occupied cells U and V values to be calculated. And on the unoccupied cells, you need to substitute and find out all are positive or zero. Is less than 0, then we need to make a loop.
Okay, if all are coming in positive way, sir, now the solution is, what is the answer, sir? Final
answer. That is the solution is optimal solution. That is the best solution.
Okay.
What is the solution means the total transportation cost, whatever we are getting, that is the best solution. Right. What we got actually 11 into 20 plus 9 into 20
10.
10
9 into 10, 6 into 30,
6 into 30 plus
8 into
8
6,
into
9.
6 9 into 18 plus 12 into this is actually the solution 1911. The best solution, which is the least cost among all other transportation costs.
Okay, when we get the positive values only, we can calculate this one. Otherwise, we can do the loop. After that only, we can calculate the transport
yes.
cost.
To show that the best solution is which solution.
Okay.
So optimal solution can be getting it only with this verification part. Otherwise, the feasibility is there. Whatever you got the answer, that is a feasible answer. Initial basic feasible solution. IBFS, we can get it by any of the method. VAM method or least cost method or northwest corner. Is that clear?
Yes, little bit confusion is there, sir.
Obviously, because once it is not possible to understand all the things. So you
Yes, sir.
need to practice once. I told you now, VAM you did not practice. So here only your understanding what is VAM. Then MODI method, again, this is the first time what you heard. So once again, go through it. Okay.
Sir, one second, sir. Sir, we are applying MODI method whether VAM is the what is it?
VAM answer is optimal
Feasible
or
or
not.
not? Optimal or not?
Optimal or
Only
not.
we are
VAM
applying
is a
MODI.
feasible. Optimal
Feasible.
solution or not.
Okay, optimal or not? For that
Optimal
only we
means
are
best
checking
solution.
MODI. Okay. Okay, sir. Okay. Understood. Give an example.
Stepping stone method and MODI method are the two methods for finding out the optimal solution that we discussed long back in the PPT. Here you can see. I told you initial basic feasible solution we can find out by northwest corner rule, least cost method or VAM method, Vogels approximation method. optimum basic solution. This optimal solution will be getting only by means of Modi or stepping stone. Stepping stone is only a 1 or 2 steps of Modi method only. The same thing. Nothing else. Modi is the ultimate. Like WAM method in the feasibility, Modi is the ultimate solution. Are you getting my point now?
Yes, yes.
So we found only feasible solution by those methods, WAM method, northwest or least cost. We did now is a Modi method to find out the optimal solution. The solution, whatever with these operations are there, that is your optimal solution. Now, is it clear or any other doubts? Clear in the sense the solution, how to do again, you need to do it once again, then only it will be clear. Because sometimes for 20 marks purpose, they may ask you by giving a transportation problem, find out the optimal solution. Most of the time I have seen in the examination, 20 marks purpose, they gave optimal solution as transportation to find out the optimal solution. So need to do WAM method at that moment. First you attempt the WAM method. With the WAM method, you do the Modi method. Okay.
Give me one negative question, sir. Negative unoccupied.
Negative occupied, it takes a lot of time again. I explained you just now. This is what actually the negative things what we did here. So, if you apply the total transportation cost, we got a negative here. I made a star here. That means here we got a negative. We made a loop, plus minus, we made it. And in the minus cells, minus sign cells, the least number of units are subtracted and added to this. So the new transportation occupied cells becomes like this. You can see in the right side.
Yes, sir.
This is what the new occupied cells cost. So again, what we need to do after loop and allocation and subtraction addition is done, again we need to go through the same thing. What steps? Occupied cells, unoccupied cells. The procedure is same again. Still, if you are getting minus sign, again we need to make a loop
Again.
Yeah.
Until you get the
reach all the values must be positive or 0.
Okay.
Right?
Okay, sir. Give us our homework, sir. Not now. Homework for negative one.
You can solve this one. One second. Yeah. You try to solve this one. With the Modi method. You can do with Modi method.
One second, sir.
See, any question given in the examination under transportation, I told you, read the question carefully, whether it is a profit matrix or cost matrix. If it is a profit matrix, you need to convert into cost matrix. Then we need to search the total supply and the demand is equal or not. Right? If that is not equal, it is normally called as unbalanced transportation. That is an unbalance. We have to make it balanced transportation by adding up dummy row or dummy column. Then to find out the feasible solution, any of the method among three methods, that is northwest corner, least cost, or garment. Any one method to be applied to find out the feasible solution. To get the optimal solution, we can go with the model.
So first we have to balance this one, right, sir?
Yes.
We have to balance first of all demand and supply.
Yes.
After that only we have to apply the WAM method.
Yes. Then to find out optimal.
Okay.
Now, in block 220, we have an assignment. Assignment is also the OR technique, which is applied mostly in the businesses where the number of machines will be there and the number of workers to whom the workers on a particular machine to be allocated so that the production will go on continuously without wasting the material and without wasting the time, so that the production can be done. So to reduce the cost also, we'll apply this. So for the assignment also, the questions will be in the matrix format. That too, cost matrix only, we must apply the technique. So the assignment is nothing but assigning the jobs to the workers on the machines or any other areas. So that is what the assignment actually. An assignment problem is a special type of linear programming problem where the objective is to minimize the cost or time of completion a number of jobs by a number of persons. The jobs has to be completed by the people only, so those has to be completed with the less time with the less cost. That is the aim of this assignment problem. And one of the important characteristics of assignment problem is that only one job is assigned to one machine. That means one worker is assigning of one project only. We cannot consider one worker with n number of jobs. We can't assign it. That is highly impossible also. So this is very important thing you need to remember. One worker, one job. One worker, one project. One worker, one machine. Where the number of jobs and number of workers will be there you can allocate according to this method. And this method was developed by the iconic Hungarian mathematician and therefore known as an Hungarian method of assignment problem. So most of the time they may ask you to solve assignment problem by Hungarian method also, they may give you in the exam. So here only one method is there as an application. There is no new methods or other. One method is there here in the assignment problems. We did all other methods, so many methods in the transportation, but in the assignment only one method, that is assignment. Hungarian method. Right. And the Hungarian method is a person, is a combinatorial optimization algorithm which solves the assignment problem in polynomial time and which anticipated later primal dual methods. It was developed and published by Harold Kuhn in 1955, who gave the name Hungarian method because the algorithm was largely based on the earlier works of two Hungarian mathematicians, Denis Koenig and are very the names we can't pronounce it properly. They can't say anything. So Hungarian method, because both are Hungarian mathematicians, so those people work is largely involved in this method, so that the Hungarian method we call it as. See, suppose there are two machines in the press and two operators are engaged at different rates to operate them. Which operators should operate which machine for maximizing the profit? Is the question arising in front of you. Similarly, if there are n machines available and n persons are engaged at different rates to operate them, which operator should be assigned to which machine to ensure maximum efficiency? So while answering the above questions, we have to think about the interest of the press. So we have to find such an assignment by which the press gets maximum profit or minimum investment. Such problems are known as assignment problems. So this is actually the difficulty or complex problem arises in the business areas also, even in normal engagement of any persons in any of the jobs. Even to transport your goods from one place to another place, and you will see the cost must be reduced. Similarly, here also, workers with the less cost can be worked it easily on a particular machine. How to work? That is important for you. So to solve any assignment problem, that is the assignment problem as I told you, will be in the matrix format, not in the questionnaire or sentence wise. It will be in the matrix format, only what we did in the transportation. Right. So to solve, there will be two phases to be gone here. We have to go through two phases. Phase one, row and the column reduction. Step 0. Why it is step 0? We have to go through that one also. Consider the given matrix is a cost matrix. Same what we discussed in the transportation. Here also, once check whether it is a profit matrix or a cost matrix. In case profit matrix given, convert into cost matrix. Then step 2, one more point. Here also we need to check whether it is balanced assignment problem or unbalanced. How to check, that we'll discuss when question comes. Then we need to go to the step number 1 as row reduction. Subtract the minimum value of each row from the entire of that row to obtain the next matrix. I repeat, subtract the minimum value from each row from that entries of that row to obtain the next matrix. Similarly, step 2, that is normally called as a row reduction. Then step 2, subtract the minimum value of each column from the entries of that column to obtain the next matrix, treating the resulting matrix as an input for phase 2. So phase 1, what we need to do? Row reduction. After row reduction, whatever the matrix will be getting, from that only we need to go through a column reduction. So row reduction, column reduction. After doing the column reduction, whatever the new matrix will appear, we need to take that matrix to solve it and get the solution. That is in the phase 2. So phase 1 is row reduction and column reduction, and phase 2 is assigning the jobs to the workers. That is the phase 2. To solve any assignment problem, we need to go through these things only. The flow chart shows you clearly. When we start, construct the effectiveness matrix if not already given. If the question is given to you in the sentence format, convert into a matrix form. That is what first he is saying. Then the next thing is row reduction. We need to go through the first phase as row reduction, then column reduction. After doing that one, we need to assign the jobs. Is the zero assignment possible? We need to assign it. That is, if yes, then assignment. Put square over the zero and cross out all other zeros, if any, on the corresponding columns. If no, then we need to draw a minimum number of lines to cover all the zeros. Choose the least uncovered element, subtract this from the uncovered elements, and add it to the elements at intersection of the lines. Again, we need to see whether the assignment is possible or not. That means, is there any single zero finding out in the row wise and the column wise? Then you need to allocate the job. That allocation is made with the right side given clearly by putting a square over the zero and cross out all other zeros for the corresponding columns. Then the solution will be getting add the elements of the given matrix corresponding to each square matrix. There we will be getting a solution ultimately. There we can solve. This is the flow chart given to us. To be clear about this, you need to understand by means of this problem, example one, by the Hungarian method. As I told you, they may give you the question to solve by Hungarian method also. When it is mentioned, it is an assignment problem. Consider the assignment problem. What is given to us? There are 4 workers and the 4 jobs. 4 workers and 4 jobs. Right. Am I audible to you?
Yes, sir.
Yes, sir.
So, them are silent, so before that there was so much of disturbance. Now nothing is there, so that's why I asked. Okay, this is actually the assignment problem. To solve it, first we need to go through the first phase. That is, 2 things need to be done. 2 steps, you can say, row reduction and column reduction. Row wise only we need to go through it. Row wise, if you see, the minimum the row is 5, here the minimum is 3, here the minimum is 4, here the minimum is 5. What to do? This minimum value is to be subtracted from all the elements of this row. So 5 is subtracted from all this row. 8 minus 5, 6 minus 5, 5 minus 5, 7 minus 5. Then the new values you will be getting, that we need to write it in another matrix. That is 3, 1, 0, 2. Similarly, here 3 subtracted from all this, you will be getting 3, 2, 0, 1. Is that clear? So from each row, find out the least value and subtract it. You will be getting the new matrix, that is row reduction matrix. Any doubt?
No.
No, sir.
Then we need to go through the column reduction. To do the column reduction, we must have a reduced matrix only, not the question, right?
Okay. Okay.
So this is the matrix after reducing row wise. Then we need to search column wise, minimum value in that row, and get the following reduced cost matrix. Then column wise least value in the first column Q1 is 1, second is also 1, third is 0, fourth is 1. If this minimum value is subtracted from column wise, then the new matrix appears. Will be 2, 2, 2, 0. Column wise, I am telling you. Again 0, 1, 3, 1. Your zeros only, and the fourth column is again 1, 0, 1, 0. That is your reduced matrix. This is what you will be getting after 2 steps. From each entry of the column, we subtract the minimum value in that column and get the following reduced cost matrix. Do you got this matrix? Do you
Yes, sir.
got this? Okay. Then after doing these 2 steps, row reduction and column reduction in the Hungarian method, row-wise search. Row-wise, is there any single zero? Because we need to allocate one worker, one job only. So in the first row, there are 2 zeros. Second row, again 2 zeros. Third row, we are having only one single zero. Right? So to this one single zero, we need to draw a box, square box. If you draw a square box here, row wise we are allocating. So column wise, whatever zeros are there, those zeros has to be cancelled. Those zeros has to be cancelled. Means this column and the row allocated one worker, one job. It means. Are you getting my point?
Yes, sir.
Again,
What is it, sir, about the column, sir?
see, when we are allocating row wise, making a square box here for single zero.
Okay.
So in this row, it is allocated, column by zeros has to be cancelled. This, and this has to be cancelled.
Okay, okay.
Right?
Okay.
Now, again in the fourth row, there are 2 zeros, 1 and 2.
3
After cancelling this one also. There are 3, but
Okay,
1
okay.
is cancelled, so there are still 2 zeros. You can't allocate it.
Right, right.
Then after row wise finish, we need to come down to column wise. Column wise, again search for single zero. If you search for column wise zero, here the single zero, make a square box for this, and row wise zeros has to be cancelled. This zero has to be cancelled. This is allocated. Here it is to be cancelled. Right? That is column wise. Column wise allocation, row wise cancelled. Your second column also we are having single zero, so this is to be allocated, and row wise it is to be cancelled, means it is already cancelled. So this is already allocated column wise. The last column will be this single zero you'll be finding out, because this one was already cancelled. So one single zero you'll be finding out here. This can be allocated. That is what we need to do. Now we test whether an assignment can be made as follows. If such an assignment is possible, it is optimal assignment. Examine the first row. If there is only one zero in that row, then make a square and cross all other zeros in the column passing through the surrounded zero, and draw a vertical line on that. Then don't draw the line. I don't mention every time. Drawing lines will be when you are not getting an object. Then starting with the first column, if there is a 1 0, then make a square, cross all over the zeros that are row, and draw horizontal line on that row. Continue till all zeros are crossed or even assigned. Either cross or assign. That way we need to. So first, in the first step, I told you this is allocated, and all other column by zeros is cancelled. So row wise is only one single zero. Now repeat the above procedure in the column wise. To go with the column wise, this is allocated and these zeros are cancelled. And here it is, this is allocated and all other zeros are cancelled. Right? Then this column is over. This column we have single zero, this is allocated. So there are 4 workers to whom we need to allocate 4 jobs. According to this, can you see once check 4 allocations are made or not? 1, 2, 3, 4. That means we got the solution for this optimal. If there is no a surrounded 0 in each row and each column, the optimal assignment is obtained. In our example, there is a surrounded 0 in each row and each column. So the optimal assignment is worker 1 is assigned to a job of 2 whose hours or a cost we can say. It may be a cost or an hours. So 6 hours. Worker 2 is assigned job 4, 4 hours. Worker 3 is assigned to job 3, 4 hours. Worker 4 assigned 1 at 6 hours. Minimum total time is 20 hours. The optimal solution is C only. You can see first worker, second job, second worker, fourth job, third worker, third job, fourth worker, first job. That is what here. First is second, second is fourth, third is third, fourth is 1. Where this number of hours from where we got means from the cost matrix, the matrix which is given to us at the beginning. That is the question. This is the thing what we got as number of hours. First worker, second, that means 6 hours. Second worker, fourth, 4 hours. Third worker, third, 4 hours. Fourth worker, first, as 6 hours. Based on this question only, we got this solution. 6, 4, 4, 6, the total it is 20 hours. This is an optimal solution in the assignment problem. Easy and quickly you can do it. Sometimes it is not possible, you won't be getting exactly all the allocations. So we need to go further steps by drawing the lines, and some more steps are there that we can discuss if this is clear to you. Is this clear? Or somewhat having a doubt?
Practical, I want to.
If you do practically, you can get it easily, you can understand. Yeah. This is another one which is unbalanced. See, solve the following unbalanced assignment problem. Only one job to one man, only one man to one job. So here there are 3 rows, but 4 columns are there. This is normally called in the assignment as unbalanced. So to make it balanced, what we need to do, one more row we need to add with the dummy values. So here is the cost matrix, you can see. There are the 3 rows given to us, extra one more dummy we added. After adding the dummy row, we need to go through the steps. That is step number 1, row reduction. Step number 2, column reduction. Here column reduction is not possible because in every column you are having 0 as the list. Right. Step 2 is not needed because we now applied 3A. Because already zeros are there in the column wise. Every column, the least is 0 only. So even if you subtract 0 from everything, you'll be getting same value. That's why no need of second step. We can go with the 3A. 3A in the sense, each row we need to find out single 0. So first row, this is the single 0. We can allocate, making a square box, and column wise these zeros has to be cancelled. These 2 zeros has to be cancelled. Then second row we don't have, third row single 0 allocated and this is cancelled. So row wise we can't get it. Column wise if you do, this 0 is allocated, all other zeros are cancelled. See, now all the zeros are either surrounded or crossed, but there is no surrounded 0 in row 2. So we don't have The surrounded zero means allocation is not there in the second row. Hence, assignment is not possible. We go to step 4. This is what the extra step I told. So these lines are drawn already. Okay. Whichever is unmarked line is there, from that we need to search the least cost. This least cost is subtracted from the unmarked lines and added to the intersecting line portion. Wherever the lines are intersecting, there we need to add this least cost, whatever we subtracted here. We need to add in the intersecting point and subtract it from unmarked lines. Whereas this marked line values, you should not change. You need to write the same thing. 4b. Select the smallest element, say u, from among all elements uncovered by all the lines. In our example, u1, u equals to 1, that is unmarked, the least cost. Now subtract this u from all uncovered elements, but add to this all elements that lie at the intersection of two lines. I told you that one. In this point of cell, here and here, you need to add this 1 and subtract it from this elements from these cells, so that you will be getting a new matrix like this. Doing this, we get the table like this. Again, we need to go through the assignment. There is a single zero, assign it, cross all other zeros. This is cancelled. Then again, if you go to the second row, you are having one single zero. So you need to assign this and cross these two zeros, column wise. Then third row, that single zero, all other zeros is cancelled. In third row, we'll be having this zero as individual zero. You can assign it. So we'll be getting like this. So there are 4 allocations made, because 4 rows, 4 columns are there, means 4 zeros or 4 allocations we should get it. We got 4 allocations here. 1, 2, 3, 4. So W1, J4, W2, J1, W3, J2, W4, J3. Like this, hence the job 3 is not done by any worker. So, and the optimal cost is 4 plus 5 plus 7 plus 0, 16. So optimal assignment got as a new. Is this clear, or else?
Yes, sir. Clear, sir.
The procedure and steps are same, but a small change when there is a possibility of This is also unbalanced one. Minimization case, unbalanced assignment problem. What you need to do is you need to add a dummy
Row.
column.
Yeah, column.
We need to add this dummy column. After adding this, we need to go through the steps. But in the step number 1, row reduction is not possible, because the row, every row you'll be finding out 0 as the least. Right?
Yes, sir.
So every row you are having this 0 as the least. So row reduction is not possible, but column reduction is possible. Step 2, we need to go through it. Here each row 0 is the minimum, so no need to do row wise reduction. Find out in each column minimum element and subtract it from that column values. Updated table is given below. Row reduction, so column reduction, the least value in this 7, 12, 18, 15. After subtracting those elements from all other elements, we got a reduced matrix. What to do? We need to assign it. If you see the first row, there are 2 zeros. We can't assign. Second row, here and here, there are 2 zeros, we can't assign. Third row, we are having only single zero. This is to be assigned here, and these zeros, column wise zeros, all other zeros has to be cancelled. Again, in the fourth row, there are 2 zeros because this is cancelled, so there are 2 zeros we can't assign. Fifth row, there is no zero left over to assign it, so here it is already cancelled. So this is allocation first, then no one crossed zero, so we need to go through the second. Allocation is made in this way. So how many zeros crossed? 1, 2, 3, 4 on, but we should get 5 because there are 5 workers, 5 jobs are there. So 5 allocations we should get. So here in fifth row, there is no assignment. So total assignments 4, which is not equal to the total rows, total columns, that is 5. So solution is not optimal. We will update the optimal solution. How to? Whichever row there is no allocation, no assignment, then we need to make a tick mark for that. Actually, this is what actually to be done to further steps. That is, cover the zero with the minimum number of lines. That is, mark as a right tick row wise E since it has no assignment. Here it is marked as right, the first one. Then in this row, wherever you're finding out the zero column wise, you make a tick. Mark tick column J5 since row E has 0 in this column. Sometimes you may have 2 zeros also. Then 2 column wise, you need to make a tick mark. Then the third point is mark tick row C since column J has an assignment in this row C. So here you made because there is no assignment. That 0 is there. Here column wise you made a tick mark. In this column, any assignment is made, you make a tick mark of that one. After doing the tick marks, no other rows or columns can be marked. Therefore, draw straight lines through the unmarked rows A, B, D, and mark column wise J5. That means unmarked rows, you have to draw a line. Unmarked rows. Here, there is no tick mark, there is no tick mark, so draw a line here and here. And column wise, wherever the tick mark is there, you need to draw a line. Such that all the zeros will get into this lines. So that you can search for unmarked cells least value. These cells are unmarked cells in which the least value is 1. Again, this 1 is subtracted from these cells and added in this intersecting point. Here, here, and here. Intersecting of 2 lines. After doing that, develop the new revised table by selecting the smallest element among the cells not covered by any line. Here, say k equals to 1 is the smallest, so subtract k from every element in the cell not covered by a line and add k1 to every element in the intersecting cell of 2 lines. So we added here, here, and here, and all these values are subtracted wherever the unmarked or unoccupied lines, unmarked lines. There we subtracted, we got a new matrix. Again, we have to assign it in the same way. Find out row wise single zero. Row wise single zero is here. It is assigned. Column wise, this 0 is get cancelled. Second row, here single 0 is assigned. Column wise zeros are not there. Then the third row, here is a single 0. You can cancel this 0. Again, D, we'll be having 2, we can't do it. Column wise, after row wise, we need to go with the column. You can see here, after all the allocations, we got again 4 zeros only, 4 allocations only. 1, 2, 3, 4 means still incomplete. What to do? Again, in this last row, we did not get any assignment, so make a tick mark. Again, in this row, we'll be having 2 zeros, so column wise, you need to make a tick mark for 2 columns, last 2 columns. And in these 2 columns, wherever the assignment is made, you need to make a tick mark. Here assign, here it is, assignment is done. Then draw the 2 lines, draw the lines. Wherever row wise, whichever is unmarked things, there you need to draw a line here and here. In column wise, wherever tick mark is there, those columns has to be drawn are 2 lines. Again, the same procedure. The least value you need to search in the unmarked cells. The least value is 1. This is subtracted from all other unmarked cells and added to the intersecting point here, 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 and here. In the 4 cells we need to add, and all other cells it is subtracted wherever it is not drawn up lines. And drawn lines you need to write as it is, it won't change. That is 0, 5, 2 as it is, 0 as it is. But here in the place of 4, we need to add 1. It is to be written as 5. Here also 2. Here 2, here 5. Whereas 0, 0, 1, 0, 0, 0, 0, as it is. There is no change. Repeat the step 3 to 6 until an optimal solution is obtained. We'll repeat it. We'll be getting this new matrix. To this, we need to assign it. Again, if you assign this, how you'll be getting? In the first row, there are 2 zeros. Second row, only 1 single 0 and column wise 0 is cancelled. Third row, we're having single 0. This is assigned and this is cancelled. And fourth row, 2 zeros. Fifth row, single 0 here and this is cancelled. Upper value is cancelled. Then column wise, we need to search. This is allocated. This you will be getting it as single 0 and this also single 0. Go through it. You're getting 5 allocations. 1, 2, 3, 4, 5. Ultimately, you got the answer. The optimal solution is A worker 3 job, B worker 4 job, C worker G5 dummy, D is 2, E is 4, so that the least cost is 54. This solution is an optimal solution. You want to do any question? This is maximization, don't go with this one. You try this one. You try this question. Can you able to see this question? Yes. Am I audible?
Yes, yes, sir.
Sir.
So you try this one as an assignment problem. So normally we'll go with the two steps first, row reduction and the column reduction. Then you find out the assignment. First you try, not able to, then I'll explain.
How only we have to do, sir?
We're not doing it.
It's assignment, right?
Doing, sir.
I thought you were doing that. So I stopped. This is column reduction matrix. Then, sorry, row reduction matrix. From this row reduction only, we can go with the column reduction. Column wise, if you see, first column, the least value is 1. That is subtracted from all the other elements. 7. Then that's 6. 0. Here also 1 is the least, so 0. 4. That's 0. First row. 5. 3. 5. This is 0. Here the least value is 2. So 4, 3, 0. This is actually the matrix which we got. Row reduction, column reduction is done. We need to assign it now. Can you do it? There are 3 zeros in the first row, can't be assigned. Second row, we are having single 0. So we can assign here.
Only 3 missions are assigned.
3 you're getting.
Yes.
Your assignment is done. All other zeros get cancelled. This get cancelled. Row wise, this single zero. Second, third row, 2 zeros. What was 2 zeros? Here, 3. Nothing is there. So column wise, this zero is allocated. This zero get cancelled. So this zero can
C4 also get cancelled, sir. C4.
3, 4.
C4 also get cancelled,
Yeah.
right?
This one also to be cancelled. Column wise, if you should go, this is allocated, this is allocated. This you won't be getting it. This is already given, this is already cancelled. This one will be allocated.
Yes, sir. C5
In
is
the
there.
fifth, C5 we are getting it. E row we are not getting any assignment. So as I
No, sir.
told you,
D0. D0 is also there. So.
Hmm.
D1.
P1 is allocated.
Yes.
We allocate, this is getting cancelled. So try to solve it if you're getting okay, otherwise I'll explain you further. Okay. Are you getting the solution? Allocation we are
Only 3
getting.
assignments.
Yes, yes.
Only 3 assignments are done.
3 you got.
No, sir. A2 also there, sir. A2. Column by.
You the assignment is made for this one, right?
Yes, sir.
And again we need to assign for this,
C5. And again.
and the C5 is allocated. There are 4 allocations you are getting. All others
In the first row, 2 zeros are there.
After rows, column wise, we have to find out.
Yeah.
In column only one is there.
Okay, okay.
These are all getting cancelled because of the allocations, right?
Yes, sir.
All these things you are getting in this way. So fifth row, we don't have the allocation. So what you do is you make a tick mark for this. This row, we need to make a tick mark that this is not allocated. How to make a tick mark? This is not allocated, right? This is needed as this is not allocated in this row. Means assignment is not done. In this row, when assignment is not there, we made a tick mark here. Here in this row, wherever you're finding out the zero, you column wise, you make a tick mark that this is not assigned. You're finding out the zero here only in this row. Okay. Once again, I repeat, whichever row the assignment is not there, we make a tick mark row wise. Then in that row, wherever you're finding out the zero, you make a column wise tick mark, right? In this column, wherever the assignment is made, in that row, you make a tick mark, right? After this tick mark, what we need to do is, we need to draw lines wherever we are not having a tick mark, you need to draw row wise a line. To draw a line. This
So in the
is
row,
one line.
second row, there is no
First
tick mark,
row,
right?
there is no tick mark.
Okay.
First row, there is no tick mark. Second row, there is a tick mark. So third row, there is no tick mark. Right? And the fourth row, there is no tick mark. Fifth row, there is a tick mark. So in the row wise, there are 3 rows where we did not mark the tick mark. Where column wise, wherever tick mark is there, you need to draw a line. We need to draw here as vertically a line. Where we mark the tick. Like this, you need to draw a line.
Sir, can you repeat, sir? Sir, can you repeat?
Sir,
Row
can you
wise-
tell me how did you choose the tick marks? Like which row we have to cancel or which row we have to keep it?
The row which wherever the assignment we didn't got, the fifth row we didn't got any assignment.
Yes, okay. That column also
That
we
is
can.
row wise tick mark we made it. In that
Yes,
row,
sir.
wherever the zero is there, column wise we made a tick mark.
Yes, yes, okay.
In that column, wherever the assignment is made, in that
Okay.
row we made a tick mark. But
Okay, got it.
after making the tick marks, we need to draw the lines. Row wise, wherever the tick mark is not there, we need to draw a line. There are 3 unmarked rows, so there we drawn a line. Column wise, wherever the tick mark is there only we need to draw a line.
Okay, sir. Okay. Got it.
Then the next procedure I told you, wherever unmarked lines are there, you find out the least value, that is 2 is the least value. Subtract from this unmarked line cells and add it to the intersecting line position as the least value, whatever we are subtracting. So 2 is subtracted from this, here, and add it to the intersecting point here.
Means we have to add the 2 only.
Two only, the least whatever subtract. We'll be getting a new matrix. Okay.
1 second.
You try this, solve it. If not, I'll be putting it in the next class clearly, stepwise. I kept it in the beginning.
So first row, sir. Sir, one thing, sir.
Yeah.
Now we have to deduct the 7 minus 2, right?
No. On the line, nothing is to be done.
Only
Wherever
keep it at
unmarked cells.
So first line, okay, we can keep it like that.
As it is, 7, 0, 0. There, in this intersecting point, we need to add 2. Here 4 as it is, you need to write.
Okay, there was 6, 4,
6 minus 2,
3.
4 minus 2, 5 minus 2. 0 as it is, 3 minus 2. The third row, 4, 2, 3 as it is, you need to write. For the intersecting point, you need to add 2.
2, 0.
0 as it is. Then 0, 2, 5, 2, 0. Then here 0, 1, 0, 0, 0. That will be the new matrix. Okay, I have another one. So try to solve it if possible. Okay, you'll be getting it. If not, we'll discuss further in the next class. No problem.
Sure, sir.
Okay. Good day.
Okay.
Bye.
Thank you, sir.
Radhakrishnan sir.
Yes, sir. Yeah. Okay, sir. Okay, sir. Thank you.
Hello, Radhakrishna sir. Good afternoon, sir. We have to talk with you.
For what?
Sir, for assignments and semester's exams, sir, we don't have any books. Sir.
Okay. So, did you not receive any books?
Yes, sir. Semester 2, assignment 3, we don't have books, sir, to write.
No, for second semester 2 or semester 3, for both.
For semester 3, we don't have, sir. Assignments 3.
First,
Sorry.
yes. Okay, then do second, and within that time I will talk to the sir, and I will just let him. Okay.
Sir, we have to submit in the Jubilee Hills, sir.
Yes. Here only.
Okay.
Yeah.
First semester we didn't submitted there. We submitted in another college, no, sir. That's why we have a doubt.
Yeah, because it is in delay actually. I don't know, but you can come and submit here only. I think it will be good.
Sir,
Okay,
actually the 2020 to 2021 batch, like that assignments are given, sir. Is it we can write, sir? We are from 2021 batch.
Yeah, I think it is for earlier batch. We mentioned there, no? Like for earlier batch also. So semester and they can able to appear. Yes.
So it is not applicable for 2021 batch, sir?
No, it is applicable. No, 2021 also they have to write second semester.
Okay. Yes, sir. Second semester.
Yes.
Okay, sir. Thank you.
Yeah, you do right, and with respect to third semester books, and I will talk to sir, and afterwards I will just give information. Okay.
Okay, sir.
You are there in that groups, no, which I am posting everyday classes.
Yes, sir. I am following
yes.
classes also, sir.
Okay, then I will see. And
Radhakrishna sir, one thing.
Yeah. Yes.
This Swarnamera 2022 batch. Hello, madam.
No, no, I'm 2021 batch.
2021 is the first year or second year? First.
Yeah, no. First year is already I have completed. Now I am 2021 to 2023 batch. I have to consider.
Yes. So now you are appearing for the third semester exams, right?
Yeah, yes.
So
Then
that means
already
you are-
మేము ఆల్రెడీ థర్డ్ వన్ అయిపోయింది కదా, సబ్మిట్ చేశారు కదా, ఇంకా మీరు ఇంకా అవ్వలేదా అసైన్మెంట్?
yeah, some people are not having information.
ఈవెన్
So-
ఇప్పుడు ఇస్తుంటే కూడా తీసుకుంటలేరు సార్ అక్కడ.
ఎక్కడ?
సార్ ఆల్రెడీ అక్కడ
ఇక్కడ
అయిపోయింది సార్. పీజీ
Paradise.
ఎగ్జామినేషన్ బ్రాంచ్ వాళ్ళు తీసేసుకున్నారు.
Hmm.
మళ్ళీ తీసుకోమని చెప్పి వాళ్ళు చెప్పారు సార్ అక్కడ సికింద్రాబాద్ బ్రాంచ్ వాళ్ళు. మేము వెళ్ళి
Okay.
మాట్లాడాము ఇన్ పర్సన్ గా.
See,
బికాస్
the thing is,
2021
this is
బ్యాచ్ వాళ్ళము.
this. I would like to make it.
అంటే
No, this
మేడం
is live
తీసుకుంటున్నారు, కొంచెం
class.
రిక్వెస్ట్ చేసి కొంచెం
Okay.
రిక్వెస్ట్ చేస్తే తీసుకుంటున్నారు, ట్రై చేయండి.
Ramya and I think Kumar, Swarna, Venkateshwarlu, and this is live streaming now. So we will discuss in WhatsApp, or otherwise you just call me. Those who are having doubt on this. Okay. We are running. Yeah.
Okay, thank you very much.